starting on the location because I'm actually going to create a terrain surface from the design surface in this file. So here you can see, like I say, it's a short section of road, and it's having the ditches deepened and widened. And so I'm just going to take this location and I'm going to save it out as a terrain file. And I'm going to call it sgdesign.ter. As-built was the terrain that was built from the survey. This is going to be my design file, and I'm going to compare the two. So I'll save this file. Already exists. Now I want to create a surface, so I'm going to use the whole entire road, and I'm going to choose the subgrade as my surface that I export, and I'm going to create a tin model, edit it in terrain, and let's go. Going to fire up the terrain file, and now I have a surface. Let's have a quick look for you. There's my surface. It's just the designed road surface only in the disturbed corridor. So the next thing I think I would do is I would merge it into the original ground so we have a more complete surface. So let's just do that. I'll open original ground. And there is my original ground survey. Now I will merge it in. Merge terrain. Merge that terrain that I just created, SG Design. Most of this is techniques that you may or may not have used already. This would be really creating a post-design surface, so that's really all I've done so far. Now I've got to regenerate the tin. I won't bother contouring it. So now I have a tin surface with the designed road built into it. And I'm just going to select this feature. Oops, there's a reason for this. When I do my as-builts, I need a center line and at least two surfaces. So I need a center line feature. So I'll save this as SG Design Merged. It exists because I did this before. And now we have our design surface. So the technique for doing an as-built in terrain is very simple. First of all, you can calculate volumes between two surfaces. So in this case, I can simply do a volume calculation. I'll browse to open the other surface, the as-built surface, which I created from the coordinate points prior to this demo. Let's just bring that in and calculate the difference in volumes between two surfaces. And there it is. There is my difference in volume, assuming that the as-built was the final and the design surface was the original. So there's a cut and fill volumes. The problem with doing stuff in terrain is that you don't get the cross-section, nice cross-section output and volume reporting by station. You only get one volume. But it's very quick. Right away I can see the volumes. And just to show you, let's add that other surface to the 3D window so you can see what's going on. So the other surface was as-built. I'll give it a little different color so we can visualize it. By the way, if there's questions, please click on your panel and we'll deal with them as they come. Okay, so there you can see where the differences are between the design and the as-built. Another thing you can do just using the simple terrain approach is to create a cross-section. I'll do that. It's going to be a draped cross-section. I'll just do it with the mouse. So I'll come across here. look at a profile of that, you can see the two surfaces there are slightly different, representing the as-built and the design surface. So that's the terrain approach. As I mentioned, it's simpler. You can do it very quickly. You can do it from a variety of sources. The next level is the location approach to doing it as built. And I thought maybe before I jump in there and do one of those, I want to introduce a couple of concepts. So let me just close this file. Don't need to save the changes. Go back to my design file here. In RoadEng, there's a way to fix cross-sections. Normally, the cross-section is created from a template. So if I go into my templates, this particular template, it's got various components. And the template, if I move it around, I'm not really moving my design, I'm just looking at how the template behaves. You can see it changes. It changes in a sensible way, depending if it's in cut or fill. So that's a template formation of a cross-section. There's another way to calculate the cross-section or to edit the cross-section, and that's using the fixed section editor. And this is something that you can do in the design process as well as in the in as-built. So what I do is I create some fixed sections. I'm going to create a whole bunch of them, and I'm going to create them at 20 meter spacing. And let me come back to what this means, start of range. Calculates the cross-section, and now I have fixed cross-sections all along the alignment. And what is special about the fixed cross-sections is you can actually go in and edit them. I can come in here and physically change something. I can do what I want with it. So it gives me the flexibility of editing surfaces on cross-sections. The downside of it is that everything is pretty much locked to the vertical and horizontal alignments. If you move the horizontal or vertical alignment, the fixed cross-sections, imagine this whole thing moving up, it's generally not going to behave very well. So if you're doing a design and you want to use fixed cross-sections, wait till you're in the very final stages of having your alignment in place before you start messing around with fixed cross-sections. And if possible, avoid using them, obviously, because then you have more flexibility. You have that intelligent template which changes itself if it's not fixed. So that's the first concept, fixed sections, that I wanted to introduce for as-built quantities. Now, you notice here when I created them, it had a start of fixed range in that create dialog box. What that means is that there were, before I started, there were sections between 280 and 300. They no longer exist. If I jump to station 275, and look in the cross-section window, it says skipped. There is really no section there. So when RoadEng uses these fixed sections, it does an equal end area calculation based on only these sections, and intermediate sections are completely ignored. If I don't have fixed sections, I'll just get rid of them, then all the points that I've got, reporting points along the alignment, are used for the volume calculations, and obviously that is more accurate. It's including more cross-sectional information. So that's a key thing, that if you're expecting equal end area calculations, you probably want to set that flag. Okay, fixed sections. The other concept I wanted to show you was that in location, you can reference other surfaces. So I'll just go in here and add another surface. I went into Module Setup and then to the Alignment tab, and I went to the Terrains function button, I should say, and I'll create a reference surface. This time, let's say add in as-built as a reference surface. There's the reference surface. And then to display it in the section, I have to go in here and turn on reference surfaces. And there it is. It's got a line type and everything already set for it. And there is my as-built surface showing on the section. And you can see the as-built surface is not tying off properly, which you might expect with a survey and creation of a terrain model, all those things. So the two concepts, one is the fixed sections, and two is the surfaces. Now, to get this all to work, you could create a template and attach the surface to the template and target it and stuff, but there's an easier way to do this. And I'll just show you. How are we doing for time? Oh, we're doing pretty good. Yeah, so there's an easier way to do this. I can create, somewhat automatically, I can create a surface, an as-built design. So the way I do that is I go, there's something, disable fast draping. Oftentimes when you have surfaces that, I'll put it this way, RoadEng expects that the topo surface includes the other surfaces. So depending on which surfaces you have, they may actually be smaller. The topo surface may be smaller. Kind of a technical detail, but when in doubt, disable fast draping. Okay, so I'm going to create a new design now, which is going to be a as-built design or an as-built calculation. Ask me for a topo surface, and in this case I'm going to use the subgrade surface, the subgrade design merged surface, which I just showed you. And then for the center line, that's why I selected the center line. It was that feature because I need a stationing alignment, so I had that center line selected. And then I'm going to, instead of choosing a template, I'm going to choose fixed sections, and I'm going to set a surface as my cross-section template, and that is going to be SG as-built. I'll set the station spacing to 20. And now we have fixed sections where the top surface is the design surface and the bottom surface, let's turn off some of the hatching here. There's a better view. So the top surface, this guy, is the design, and the bottom surface is the built. And of course, now you get volumes between the two surfaces, the subgrade cut and fill. You can do everything that you can do in RoadEng. You can print out a series of cross sections. You can get notes, other information based on these two surfaces. Now, one thing we might like to do is, let's just remove the fixed cross sections again. Let's bring in the original ground surface for reference. Okay, same thing I did a few minutes ago. I go into Setup, Location Setup, Terrains, scroll down, and this time I've already got reference terrain 1 used. So I'm going to use reference terrain 2, and I'm going to put the original ground surface in there. And then again, I have to turn on my section options, reference surface, display him with a color that we can see clearly. So there's the original ground. The black line is the design surface. The red line is the built surface. And regenerate my fixed cross sections. Yep, 20 meters spacing. No, sorry, this is wrong. 20. Turn that on, turn that off. Let's go with that. And here's, again, start of range to exclude those intermediate sections. And yeah, so now you can go in and if you wanted to tie off the survey, which is in the subgrade, topo is actually the design surface, so you could come in here and fix things like this. And again, you can calculate volumes. And you can switch the surfaces. I could have, instead of design versus built, I could have compared built versus topo for maybe for pay quantities and things like that. The last thing that I want to look at is very quickly look at the templates, because what's going on here when the templates are created, it's actually creating this template, a follow surface template, where these surfaces in the template refer to those surfaces that I've set up. So with this functionality, you can add many surfaces to this. You could have a strip layer, you could have a subcut layer, and you can calculate volumes between the two surfaces, which it does require a bit of careful planning, but yeah, you can do multiple layers all at once in the same design file.